remind me, what was the formula for the surface area of a prism? You're thinking of the volume. Okay. Guys, have your notes out. It's good to have those other notes out because it helps you remember.
Have a good day.
There you go. Okay. So the surface area of a prism is the perimeter times the height. Okay. Okay. So it would make sense that if we're dealing with a pyramid today, instead of having rectangles for the sides, we now have triangles for the sides, right? How does a triangle's area relate to a rectangle's area? It's half, okay? So instead of having the perimeter times the height, we have half the perimeter times this new guy called L. So your little guy, your slant height, is your L. So now instead of talking about the height of the prism, we're talking about the slant height of the pyramid. The slant height goes from the vertex of the pyramid perpendicular to the base. And it's actually on the face of that triangle. Okay, so make a note on here that L is the slant height, not the perpendicular height from the top to the middle of your base. L is the slant height. Okay, write it down. Okay. Now, this works, this formula works, or these two formulas work when this is a regular polygon for the base. Remind me, what does regular polygon mean? Not so much about curves, because that's a polyhedron, right? But all of the sides are equal, and all the angles are equal, okay? So this formula, these two formulas work when we have regular bases. All four sides equal has to be a square, or an equilateral triangle, or a regular pentagon, and so on. Okay? So if my lateral area is half of the perimeter times the slant height, I take 1/2, and how do I find the perimeter of this base? Good. Count by 12s, or 4 times 12, because there are 4 sides and they're all equal. Okay? And what's my slant height? So what is half of 4? 2 times 12 is, and 24 times 14 is 336 meters squared. Okay, area is always in square something, square units. So that's one answer. Now I need to find the total surface area, and that was similar to what we saw yesterday or 2 days ago when we found the total surface area of a prism, only we had the perimeter times the height plus 2 bases before. We only have 1 base now. Okay, so the formula's changed a little bit. Yes, sir. And it's still going to be half because these are triangular faces now instead of rectangular faces. Okay, so similar to what we had before, but less, right? So here's our half PL. Let's just rewrite the 336. We don't need to calculate it again. And how do we find the area of the base if it's a square and each side is 12? 12 times 12, length times width, side times side. So 12 squared, which is 144, so 336. And that becomes 480. Okay? We're good with that one? So pyramids work the same way. Write the formula, pick the right formula, write it down, and then substitute numbers in. But be careful, capital P means perimeter. I have to find the distance around that base. And L is now a slant height, not the perpendicular height that we were used to seeing. 336 just came, we just rewrote it. Yep, no need to recalculate it, we just did. Okay. Other questions on this slide? All right, so let's do one more so we know how to do this. Now we have a square pyramid again. Remind me, what's the formula for the lateral area? This time, what is my perimeter going to be? 7 plus 7 plus 7 plus 7, or 7 times 4, because each of those sides is 7. And what's my slant height? So half of 28 is, and 14 times 5 is, so 70 square centimeters. Okay. That's half of what we need to do to find the total surface area. Total surface area is half that perimeter times the slant height plus just one base. And that capital B is the area of the base. So again, we have a square for our base. How do we find the area of that base? 7 times 7, length times width, side times side, whatever you want to call it. So 7 times 7 will be 49. And we're going to take that and add it to the 70 that we had from our lateral area. So 70 plus 49 is how much? 119 centimeters squared. The 49 came from finding the area of the base, and the base is a square. So you can do base times height or side times side, but this is 7 and this is 7, so it will be 7 times 7. Okay. All right, now volume. To find the volume of a right pyramid, doesn't occupy as much space. In fact, it occupies a third of the space of a prism. I can take 3 of these pyramids and set them in the same size prism that are the prism with the same base and height. Okay? Trust me, it works. Okay? If you had a pyramid that was the same size as a prism, as far as dimensions are concerned, length, width, the base is the same size and the height is the same size, we could fill that pyramid up 3 times and dump it into that prism. Okay? Yes, sir. Okay? So 1/3 the area of the base times the height. Now, be careful. This is now h, the h that we've been used to using. Okay? This h is the perpendicular height, not the slant height. Everyone see the difference? Looking at your drawing. Slant height for lateral and total surface area. Vertical height for the volume. Make sense? All right, so V will be equal to 1/3. How do I find the area of the base? 15 times 9. So 15 times 9. And then I need to take that times the height, h. And h in this case is 8.5. Okay? So question comes up, how do I do 1/3 in my calculator? Well, if you look at this and say 15 is divisible by 3, right? What's 15 divided by 3? 5. 5 times 9 is So we're taking 45 times 8.5, and we get, and now my units are going to be what? Because we're finding volume. Inches cubed. Okay? What questions do you have on this slide? Only the third of one of them. Okay? Well, you can either take a third of 15 or a third of 9. Or I could have taken 15 times 9 times 8.5 and divide all of that by 3. Whatever you want, however it works for you. And there's also an ABC button on your calculator that lets you make fractions. So you could use the ABC button to find 1/3 times 15 times 9 times 8.5. Yes? That's all you have to do for all of us. Unless we give you the back way and say, here's the volume, or here's the volume, tell me the slant height, or the height, or find the one of the lengths of the width of the base. Okay? It's a worksheet, but we want to talk about cones first. Okay? So the right side of this is about cones. Okay? And remind me, what was the area for, or the formula for the lateral area of a pyramid a moment ago? Okay, 1/2 PL. What is the perimeter of our base here? It's a circle, right? How do we find the perimeter of a circle? That's area. How do we find the perimeter? The circumference, right? Pi r times 2, 2 pi r. So this is no different than saying 1/2 times 2 pi r, right? That's our pi r. It's coming from our circumference formula. Okay? So pi rl is going to be my lateral area. What's my radius? 3. What's my slant height? 5. So 3 times 5 is, so 15 pi inches squared. Nolan, put it away. Now we want the total surface area. Plug your 15 pi in, and we're going to add just one base this time. We don't want the whole 2 bases. It's not a cylinder. It's only a cone, right? So how do we find the area of a cone, of a circle? Pi r squared, right? So what's my radius? And 3 squared is, so 9 pi plus 15 pi is how much? Inches squared. You can multiply 24 and pi in, and you can get a decimal, and that's okay. This is just more accurate. I asked you to put your phone away. In just a moment, I have one more example. Okay? All right, yes, Megan. Absolutely, absolutely. So there may be times when they don't give you L, okay? So watch up here, guys. They may have given you this instead. Okay, can we use this height? That's a 4. Can we use this height? We use this to find volume, right? We use the slant height to find the total surface area and the surface area, right? The lateral area. So we have to sometimes watch and be careful that they gave us the right height. And if they didn't, we recognize that this is a right triangle. A 3, 4, 5. 3 squared plus 4 squared gives me 5 squared when I use Pythagorean's theorem. Okay? So be careful because they may try to trick you, and they may give you the wrong height, and you need to find the other one. They may give you the vertical height when you're on a surface area problem, or they may give you the slant height when you're doing a volume problem. Okay? All right, last example. Okay, this is the last lateral area and surface area example, and I've got one volume problem. So real quick, what's the formula for lateral area? Do you see how writing this down helps you know what to plug in where? Okay, so write your formulas every time. Radius is 4. Lateral, the slant height is 7. So 28 pi. Okay. Now I want to find the total. So I take that pi RL and I add on just one base, pi r squared. So the 28 pi jumps in this spot. My radius is, so I square it and I get, so 16 pi. 28 pi plus 16 is 44 pi. Okay, makes sense? All right, last example. Okay. Volume. Okay. The volume of a cone is similar to the volume of a pyramid, right? It's a third as big as the cylinder that has the same dimensions, radius-wise and height-wise. Okay, so V will be equal to 1/3 pi r squared h. Pi times, what's your radius here? Careful. What's the radius in this case, guys? They gave you a diameter, didn't they? Okay, so don't let them trick you by giving you a diameter and using that number. Okay, so what's half of 13? 6.5. Okay, so times 6.5 squared times 18. Is this the right height for volume? Yes. This is the h. We're good. Okay. So you can take 6.5 squared times 18 and divide it by 3. Or we could take 18 divided by 3 and get 6, right? And take that times 6.5 squared. And our answer will be 253.5 pi inches cubed, because it's volume. And if you multiply the pi in, you'll get 796.4 inches cubed. I'll take either answer. Okay. Did I make a mistake? Mm-hmm. Yep. Yep. Mm-hmm. And then you divide it by 3. And the pi can just hang along. Okay. Okay. Yes, question. Mm-hmm. Mm-hmm. Yep. It doesn't matter which order you do it, because they're all multiplication and division problems. Okay. Are we good on this one? Okay, so it won't mess you up if we turn the cone upside down, right? Okay. And here's a trick. Okay. If I have a cylindrical cone, right? A cone versus a cylinder, you get 3 times as much ice cream in the cylinder that has the same dimensions, height and radius wise, as you do a sugar cone. So when I don't want my kids to eat as much ice cream, I buy sugar cones, and they get a lot less volume in the cone. Of course, they stack just as much on top, and they get the sugar instead of the regular cone. Okay, last one. If I give you this, can you still find the volume? Exactly. Cavalier's principle. Yep, same thing applies for volume. Okay, we would still have to find the radius, right, which is 6. And then we would have to use our vertical height, 13. Okay? All right, let me get you the assignment.